What do we want? A costing app. When do we want it? Yesterday. Jokes aside, I really needed something similar to this myself, so I don't have to keep paying $300 for the software that I set up my architectural plans in. So it made sense to make it for both of us. It is modelled off of my design, but it'll do basic sheds as well, because essentially I am building a basic shed with some lining and cladding and internal framing, so so it'll do all of the above. Essentially, it's going to tell us if we haven't got any products to match against, things that we're trying to measure and cost out. It's going to give us unified dimensional cutting optimization, which I've had 7 goes at programming now. Essentially, it's going to tell us how many pieces we need, what the cut lengths are from those pieces, the specs for those pieces from our product guide, and our seating rule. I'll explain all of this to you as we go, so don't get too tied up in what they are, but by the end of it you'll understand. It's going to tell us what products it found in our product catalogue that match what we can use, and it's going to choose one of those according to the optimal solution, but you can change its selections later as well. It's going to tell us how much waste there is from each of these cuts. For example, 34 pieces cut at 2896, I'll explain these figures to you in a minute, is going to leave 104 millimeters waste. That's 3.5% of that total material. And then it's going to give us an ex-GST price for all our totals, or it'll give you an ex-GST price per order. The reason I'm doing ex-GST is because you might mix up suppliers. So if you're getting absolutely everything from the exact same supplier, then it makes sense to add the GST. But if you're just going to order a bit of this, that's going to have a GST, and a bit of that from someone else, it's going to have a different GST calculation. So that's why I'm doing ex-GST. So that's our 1,000-foot view. How are we getting this data? Let's get into it. Let's talk about the prerequisites and why I chose to do things this way. One of the first things is you have a prerequisite that I also have, and that is that it needs to work offline, because I don't always have mobile reception out here. I understand that some of your job sites you have no Wi-Fi reception, so you can't get internet. So that's the first prerequisite. That limits how we can design this, or how we can make this operate. Traditionally, a program like this would use a database for the back end. For you to run a database on your machine, about the most optimal way you could do it is to install a local host and grab something like SQL or SQLite, and that is going to be complex. It is offline. It means that your computer acts like a web server of sorts, and so because the app lives on your computer, then it's being the web server. It doesn't need the internet connection. Nonetheless, it is complex, so I wanted to simplify that as well. So what I settled on was what we have here. It's going to be a little exe file. You double click it, it opens up. If it's got no data in it, it's new, you haven't imported anything yet, you're going to see this screen. From this screen, you're going to bring in your product catalog and your basic designs. So, for example, if you're doing a shed, just a simple shed, no lining or anything like that inside, it's just a tin shed. And let's say, for argument's sake, it's got a gable roof. That means that you've got 4 walls that we're going to call panels. So you've got 4 panels you need to build. And then you've got a gabled roof, so you've got 2 more panels on top. So all up you've got 6 panels. Each panel is going to have X amount of material that goes into it. That's how I have devised how the program will work. And this is how you'll get your data into the program. Because I wanted to test different scenarios for importing data, I made 2 separate workbooks. They are in Excel format. I'm just viewing them in Mac's native spreadsheet program called Numbers, but they are Excel format. I basically have a Studco product catalogue. I just made up prices so that we had some numbers to crunch. But these are actually their products and their actual product codes. So I just copied them out of a PDF. But you know what it's like, they just don't give you prices. You gotta hit the quote button. The point of making such a huge list is to make sure that my code picks the right products and, fits them in. We've even got, a few oddities here that the code should sort out. We should end up with 3600, and these 300 on center, 450, 600 should end up in our materials data sheet. That's the plan anyway. At this stage I haven't coded absolutely everything. I just got enough coded that I can show you a demonstration of what's doable. That's the product catalogue. It's one single sheet. And then the other scenario I would like to test is to make sure that we can see multiple sheets, and you can select which sheet you want to import your data from. So that's the second scenario. Again, Excel format, standard, columns and rows. So what we can do is set you up with some template sheets like I've got here. These are obviously filled out a little bit because I'm using them to test, but I can send you some template sheets with just, the column names at the top, and that way you can plan it out already in the language that my code's using, and things will be a little less complex importing them into the app. So long as your product code is in your product catalog and you've got your width and length measurements, those are the most important things. Everything else here is redundant, I guess price as well. When it comes to ordering steel, you probably already know, you've also got a BMT, which is the thickness of your material. So I've used that terminology. I've used width, depth, length and thickness, or BMT, just so you're familiar with those. I've used that language because Studco does, and I assume most suppliers are going to have similar language. And the point here too, before we go on, is that I don't want to touch your data. I want your data to stay your data in your Excel spreadsheets. The only reason we're touching it at all is to bring it into my app, and then from my app we can do what we like with it without changing your data. Your data will be the source material, and then if you want to export from this app, we can arrange how to export it and dump a sheet into one of your Excel workbooks. That's all doable, but I haven't actually coded it yet, but it's all doable. So we just defined a project, which is a shed with a gabled roof. So it's got 6 panels, and each of those 6 panels is made up of multiple materials. So what I've got here is just a list of materials. They're arbitrary, well, they're actually based on my own design to cover all of the columns and how the app is going to use those column names and why we need those to match. So essentially I have a list of 1 to 9 materials that are going into each of my wall panels. I have a stud. It's measured in linear meters. That's its width, and that's its height, and that's its depth, and that's its BMT thickness. And the slot means it's a hollow material and one piece slots inside the other. So that slotting, which is the depth of 32, needs to be accounted for in our lengths. We need to make sure that there's 32 at the top to slot into the head track, and then 32 at the bottom to slot into the bottom track. If you're working with timber, you'll use a butt. So you timber a butt and then you shoot your nails in from the side, or however they do that. And then noggins are going to have two different combinations. If you're working with steel, you've got a continuous length of noggin, which is segmented by punched holes. And the reason we're defining this is because if we say we need 7 lengths but one's got to be cut, we don't want any of those cuts to be in between punched holes. We want them to be right on a punched hole, so then it falls on a stud. When you're working with timber, they're still segmented, but they're not continuous, so they're segmented into separate pieces. So that's what we're doing with the seat rule. We're saying, how does this material seat against another piece of material? Does it slot? Does it abut? Does it overlap? Or is there spaces? That's all of the different options you've got for seat rule. When we're talking about application, the app will use these to do the measurements. So linear just means basically we're telling it that these are measured lengthways. When it's segmented, we're saying it's either got an offset of 300 or it's cut into pieces that size. Because I wrote punched in the seating rule, then the app knows I'm talking about offsets and that these are going to be continuous segments. Coverage means an area, so you've got a height and a width. Plasterboard, cement cladding, colourboard cladding, they all cover an area, so that's coverage by area. So those are the applications that the program needs to know, so we know which way we're measuring in the materials. And just to give you an example where it's going to be different as to why I went into so much detail, plasterboard is usually laid horizontally, but I don't have the stud layout for top to bottom horizontal, so my plasterboard's going to have to be laid vertical. And there's two reasons. The face of the nogging section is only 28 high. As you can see here, my noggings are only 28. But the NCC rules say that it's got to be 32 or more. So I can't use the nogging to do joins in 1200 wide, plus it's further than 1200 down the wall. So it's not going to reach that way either. So those two things mean that I've got to use plasterboard or cement sheeting in the vertical direction, which is not standard. And I've got a way to be able to determine that in the code as well. We'll get to that next. Things like cladding have an overlap. So the depth here is being used to calculate the overlap. Batten cladding has a spacing, so they don't necessarily abut each other. They are spaced out. So if you've got 300 between your screws, 300 millimeters between your screws, then the next batten can only be placed, at 250 for a screw to land on it. And then from the outside, it actually looks neat. Cladding battens are going to be spaced. Cladding itself is going to be overlapped, so we're going to use the depth column for that. Spacing would use that same column. Any other calculations that require the depth, you will add it here, but I'm just putting zeros there, so if there's any accidents in the code, it just does nothing with 0. And studs slot into each other, essentially. So those are the rules. That's what the depth column's being used for here. Let's talk about the panels that we're going to build. So we want 6 panels. We want 4 walls and 2 roof panels. Right? So over here, I've entered 2 panels in. I mean, obviously you want 6. Wall panel 01 all the way to 6. You want to be able to say which project it's associated with. So I don't know what you use for project IDs. I just made one up for the purpose of the exercise. But I'm sure you have project IDs, or some way that you define one project from another. For me, this is just a human readable, what makes sense to me. For this is telling me the panel I want to measure and quote is the first wall for the bedroom and the first wall for the ensuite. They're kind of joined to each other, which makes up one wall. And then this one is saying the living room and the shower. So I've got a standard bathroom and an ensuite, but I didn't want to use B again because that's for bedroom. So to me, that's what those read. You might use some other language. The panel type, whatever helps you describe the panel type. For me, these are external walls in traditional sense when you're talking about framing. The system I'm building in is steel. You get 2 options, steel or timber. These are the lengths of those 2 rooms added together. They're identical lengths. This is my ceiling height. So this is my unfinished ceiling height. So from unfinished floor to unfinished ceiling, that's our stud height, basically. When we're talking about end studs, we're saying, does each panel have an end stud, or does it join onto something else? But we do have end studs, and there's a reason that that's important. I'll jump over to my own floor plan shortly and just show you why that becomes important, along with the rest of this information. Clearly a top plate is the top run, and then your bottom plate is your bottom run. In some timbers or longer spans, you want to double those up. So you might have 2 top plate counts, or you might have 2 bottom plate counts. But it does say count, by the way, so you can see it. But in my design, I only need 1. And then these 2 values here, external cladding left and external cladding right, these are offsets. We can jump over now to my design to explain what those 2 things mean and why I'm talking end studs. So, as you know, I'm not a builder, so I'm probably using terminology that's not common to builders. And that's the reason I'm going through all of the terminology that I used, because you as a builder know exactly what I'm talking about once you see it on the screen. So I'm just using layman terms because I'm not a builder. In my structural plans, the engineer defined 2 types of walls. So the exterior perimeter of my building, and then the interior walls, or the partitions between rooms. So he's defined a 50mm stud, which is actually 51 in stud code terms. So obviously he didn't even read the manual. And then he's got 75 for my interior walls. And that probably doesn't make sense to a builder until you understand the structure of the wall that this is going on. It's already framed in steel. So this is a lining wall that gives me a space to put more insulation in to meet the codes for thermal shell 7-star rating. So it's probably not going to make sense why the engineer has given us these little skinny studs and then big fat ones inside, because it's usually the other way around. But for this design, it's part of meeting the code. So basically, when I say an end stud, I'm saying, well, here's my panel. It's not necessarily an entire wall. I, in fact, need multiple panels this size to do that entire wall. The demonstration data that I'm using, I'm not using that theory, but this is what I want the app to be able to do. For me personally, I don't know how you build your sheds. you may need some kind of structure like this. So essentially, you know, these need to be 950 wide, these need to be 300 on centre, out of the specific member sizing that the engineer has specified here. And so at the top here you can see that it slots into the head track, which is your top plate, and then it slots into the bottom plate track as well. And then my nogging is going to be a continuous run with holes punched in it at 300 on centre. Being a builder, I don't think I need to explain to you the difference between timber and steel builds here, but that's what we mean by do we need end studs on our panels. And then over here you can see we've got a much wider spacing. We're at 450 here, 450 spacing in the 75 Studco stud range. So for offsets, something I wanted to just sort of play with in coding, it might not even be relevant here, but now it's in the code, might as well stay there. You can just set these to 0 and it won't calculate them. But for me personally, let's go to this one here. So this is my end wall here, and what I'm calculating is going to be, you know, how many of those frames are going to fit that inside line there. So because these are inside studs, this black line here is the other material, which is going to offset my interior studs to my exterior wall paneling. If you know that thickness of the wall, you want something that's going to span your interior floor, and then you want something that's going to be the same length, but it's going to be offset by the thickness of whatever you've got on the outside. For a regular timber build, that's going to be, I don't know, probably OSB, sarking, and some sort of battening and blah blah blah. So that's where you can add that offset. So this length here on the outside of cladding is going to be offset on the left by whatever the thickness is of your material versus what you were measuring on the inside floor, the clear floor area. That was the point of doing that, so it could give you a couple of values rather than just you've got to do a separate calculation for if you've got, see, I have, you know, I want 1, 2, 3 materials to be quoted. I might as well give it the same lengths and just specify what those materials are. So for me, it's going to be an interior frame at the Studco 51 by 35 studs, and then I've got all this material in between, which is going to make my offset, and then I've got battens that run horizontally along the wall, and then the colorbond cladding goes on top of that. For me, that's what I want it to do. You don't have to do that. You just put 0 for these if you're just doing a straight frame for your exterior, this black line here, just do that. Forget about the offsets. But it does help if you want to calculate, you know, the same thing. Instead of doing a separate calculation, it can do it all at once with some sort of accuracy. Alright, and the spacing, as I said before, is going to be, if you're talking about noggings, it's going to be this, what your off-center measurements are. Mine here is 300, over here we're 450. So I've got different walls with different spacing. If you're doing timber, that spacing's different again, and depending on whether it's a load-bearing wall, you're going to have 2 top plates and or maybe 2 bottom plates. It depends on the application. So being a builder, you know when that's applicable. I have no idea. Also, when you're doing your timber, you're going to have these staggered as well. You might have more actually than just the one. And while we're on that topic, this is the other thing I was talking about the sheeting going on horizontally. That face there actually is not a wide enough face, and that building codes won't let you attach your sheeting to your sheeting joins to that smallest face. So that's why I've got to put them this way, because now they're 36 wide on the sides of my studs. So that's why I did that. Now, it might seem complex that I'm explaining all this to you. Firstly, it is because of the jargon, but it's also because of the math. When you're trying to model something that our brains think automatically, they're going, no, just whip out a tape measure, measure that, measure twice, cut once. But when you're modeling how your brain is going to do that, it becomes a little bit more complex. And so I'm trying not to get too far into the complexity of modeling how our brains do that, and more about matching the language that I'm using in the software to what you know as a builder. Now we can get into how to bring that data in. Probably the most important thing to remember is you don't need to use these spreadsheets. You just know what I'm looking for to get the math working. So you might have different column names in your current spreadsheets. You don't have to change them. You don't have to use a template. You don't have to do any of that. It's just I can provide it because you want to test all of this so that it all matches and make sure that my maths is right. I also need your feedback on which parts I got wrong because I'm not a builder. So anything in there, like the wording probably is a bit of a pain in the backside to change because if I've used spacing underscore millimeters throughout my code, it's currently 3,000 lines of code before I even get any further in developing. But it means changing it on, every second line. So apart from the words that I've chosen to put in the code, any concepts I've got wrong, or anything I'm computing in the math that isn't coming out right, that's why I'm going to give you the template sheet so you can put some solid figures in there, feed those into the app, and make sure that my math is all adding up how it's supposed to. So that's the purpose of giving you some spreadsheets. The other way you can do it is simply map your column names into what I'm calling spacing, or what I'm calling studs, or what I'm calling top plate or bottom plate. So that way we're both on the same page and the codes speak in the same language as we are. So now we've got all the jargon out the way and our panel structure described, this part will make a whole lot more sense. So the Bear app has no data in it. We're just booting it up for the first time. It's got nothing in it. So we need to import your data. And what we just described and what we went through is going to help you match your column names to the variables in the code that are being used to make the calculations. So the first thing you need is your product catalog. And we were using a stud code product catalog, and these are our column names. So when we're importing, we're just asking for this column name. We'll see a preview of some of the data in there just to make sure we got the right sheet. It's easy to click on the wrong sheet, so but you'll see 3 or 4 rows of data just to make sure you're on the right, your most current sheet. If you're like me, you've got 3,000 of them of the same thing that you change slightly between one and the other or whatever. So that helps you sort of identify which sheet you're after. But the thing we're focusing on is matching these column names to what the code's going to use to do the calculations. So I'm going to leave it at stock product catalog because that's the first thing I want. So I'm going to choose the spreadsheet, XLS, open, and there we go. We can see, because it's only got a single sheet, it hasn't given us any options to choose a sheet, which is how it's supposed to work. So that's the sheet. It matches what I'm after. This row 1 is the thing we're matching down here, and there's a bit of sample data. That's my latest version of the sheet. I'm happy with that. So now I just need to map my variables to your columns. So if I want to specify a product code to you in your quote area, that's where I'm matching that to your product code. I want a description that's just human readable. Description, don't necessarily need that in the calculation, but we do need it to punch out to you what product we're talking about, rather than just hitting you with a code. Width, it's called that on the Studco sheet. Length, it's definitely called that. Depth, it's called that. VMT is definitely there. And we have a weight, which is kilos per piece, and we have a price. So let's import all of that. It will give you a message: stock data is imported successfully. You can now import more data types. So that's our basic necessity. What stock are we going to be measuring all of our panels against? So the next thing we want is, what are our panels made from? So let's grab our panel material. So in here we were going to go to the materials. Okay, let's grab that. New layout. Open that. And it says select the sheet. So these were the two examples I thought we could use to see that the data import works. When you have a single sheet, it just shows us a single sheet. And when you have multiple sheets, it lets you choose from whichever sheet it's in, the data is in. So choose a sheet. I've called it materials in this XLS. So we need to make sure that row 1 column names match what I'm using in the code. And obviously it will here, because I designed it on this code. Yours probably won't. So what are we? Application, width in millimeters, height in millimeters, depth in millimeters, offset in millimeters, thickness in millimeters, and what are our seating rules. Alright, so that is our materials. So all you need to remember with your materials is each panel can be made up of multiple materials. Might only be one. If it's that simple, you're just doing a straight frame costing, then you would only have one row, one material, one product, one row. But I want to do multiple. So I've got some openings in different places. So I want certain materials for my cripples, and I want certain materials for my sills over my openings. So that's what we're doing there. One panel, multiple products. So we'll import that. Yes, we want more data types. So now we want our panel data. We want the sizes of our panels and whatnot, which is in the same spreadsheet. I'm going to call that panels. So I need which panel it's associated with. Sorry, which panel I am calling that set. So, you know, panel 1, panel 2, panel 3, whatever you're going to call it. And they have to be unique too, because we're going to quote you by panels and then bunch all your panels together, so that needs to be unique. We need a length, and we need a height of our panel. Basic information. I put project ID in there so that you can define panels for different customers. So panel name is just your human readable name for this for that customer or project. Panel type tells us whether you're doing an internal wall, an external wall, or whatever type of wall. The system is really important. The system is actually whether you're building in steel or timber, so there's different assumptions that the code makes, whether it's steel or timber. And studs, you can have those at 0 if you want. top plate count, bottom plate count, and I do have some offsets, so I'm going to include the offsets. I don't necessarily need the notes, we can leave that out. Why not just put them in anyway, because it helps me remember which is which. Let's finish that import. So that's our panel. So that's telling us we've got the main details to do our calculations. There's one more sheet which we were talking about how to assign those panels, those materials to your panels. This is just a database trickery, which is why we have it. So essentially, which panel, what's the material over here? That's this ID. What's the material, and do we want it vertical? That, as I said, was just to give you options on laying things vertically, horizontally, or bracing on an angle. So if you do have panel materials, you can import them now, but if you don't have panel materials already set up, I'm going to show you how to create them in the program. So I'm calling it panel info, and that matches what I want. Panel ID, material ID, and what the orientation is that we're measuring. Let's go create import. Alright, so that's all our data. We're all in now. So let's go to validate. Okay, so because we're in design mode, I don't have a lot of things designed. I've got enough to show you what my ideas are. But what we would like here is some boxes, so you can change things here. Probably not the product code, but you might want to change the description. You might want to change your dimensions, or you might want to go all the way to the bottom of this. You might want to add a product. It'll give you a new row with some boxes to fill out. Or you might want to remove a product. And I really have this in the wrong spot. It should be at the bottom of the page, but we'll just get that out of the way. But this is what it'll look like. Some boxes to enter, so you can change things around a bit. So nothing is stored in the program at this stage until you finish this step. When you finish this step, it'll be committed to, rather than database, I'm going to use JSON, which is similar to a database, but it's text files basically. Difficult to explain, but anyway, we're substituting a database, so you don't have to do any extra work in setting up a program to work with a database. So here you'll just fix anything that is incorrect. Material for each of your panels. I've got studs, I've got cripples over my door headers, I've got sills over my door headers, I've got tracks across the top and hems across the bottom. I've got noggings, linings, cladding and batten. So that's what I want everything to be measured in my code for each of my panels. So down here I've just defined a wall panel, WP for wall panel. This is my human readable word for it, what I'm calling it, the type of wall I'm calling it. And so I've just put in a full length wall, and I'm just saying let's pretend we've got no end plates, and I'm doing these 950 wide panels just for the purpose of the exercise. And I want it to be made from steel. You can change that to timber if you're doing timber. And then you see that this is really wide because we've got all of these materials associated with this wall. And if you decide, you know, I want to switch my material out, if it's not in the list, then you'll need to go up here and add a new material. So all those materials that you specified would go into this wall are being listed here. So you might say, yes, I want that internal wall stud, but man, I don't want that specific plate ID. I think I want, you know, a bit of timber there. So you can change it out by adding a material, page will refresh and it'll put a new material in here for you to choose. So, but if you do that, also remove the one that you're replacing it with, obviously. So if I don't want that top plate, I'm going to add a new top plate. Remove that one first and then add your new top plate. Then it will pop up here as an option to add to your wall material. And if you screwed something up, you can remove your wall altogether and you can add a new wall. That can all be changed here. That's a redundant table. It's just showing us how we assigned our materials in the database. That's a redundant panel. That's for me only. It won't be there when you get it. So let me have a look. Issues found. 8 panel material records missing orientation. How did that happen? Right. This should happen automatically. As I said, I've got debugging features at the moment so that I know when things are messing up. So here we go. I press the optimize button. So it runs through, this is the length of material we need, what's in stock that matches, the lengths, the cut lengths that we need. Obviously 3 meters is a good choice because they're going to be 2896. So it'll choose the 3 meter stock. It'll say I need 34 pieces of that. And I'm going to cut the 3 meter stock at 2896. I'm going to have 104 millimeters waste. These, I will collapse these so that they're not such a long list, and you can look at them if you want or not. But that's a summary. If we have a different suggestion, because some other stock matches better or it's cheaper or whatever, you'll see that listed here in this bottom box. So this is what you've specified. This is what we're recommending, and this is how we're going to cut each piece to make that recommendation. Same with your top plate. It'll go through all of your materials and basically say, these products match. Again, optimized, how you would cut that. So only one piece out of 1 piece out of 5 will have 330 millimeters of waste. So the percentage here is waste from the percentage of the total number that you're ordering, so minimal waste. And these are not listed because it's telling us right up here at the top, I don't have any internal wall lining in my product catalogue, I don't have any external wall cladding in my catalogue, and I don't have any wall battens in my catalogue. So did that on purpose so you could see the thought process of the code in action, how it's going to tell you, hang on, we can't finish that calculation. So you'll see down here it says, no matching products found. Either source this material separately or find alternative specifications. So I would at this stage go back to validation, and I would add those products here. Add your cladding, whatever it says you're missing. Goodness gracious. I should put this at the top so we don't have to scroll through everything. Thought for later. Put this at the top so we don't have to scroll everything. So there you go. New product, add your product, and then when you go back, it'll tell us that you've got a new product. So one of those things, if you only add one product and go back and look, one of those error messages will not be there anymore. Obviously, there's some logic missing in my code, but we've got the basic logic down pat. That's how it's going to work, and I'd like some feedback.